Hello world, today I'm going to teach you how to write a Perl program that will compile C++ projects for you. Why is this necessary? Well, let me give you a little bit of background. I love programming on Linux. I love writing software for the Linux platform. It is so much better than Windows in my opinion in almost every way. But if you compare Windows to Linux, you can think of Windows as a completely built motorcycle. It'll get you around. It may not be very fancy, but you can do just about anything you need to do on it. But it's just that. Nothing customized. It may not go very fast. It might not have certain features you want. Linux, however, is like a box of motorcycle parts. You can build a wonderful custom motorcycle that's beautiful and fast and gets you everywhere you want to go with all the features you want on it, but you have to build the motorcycle. So that's what we're doing here. We're building a part of this motorcycle for Linux, so to speak. Let's get started. Now this first line here, this is called the shebang. User bin Perl. This part tells the shell interpreter what interpreter we want to read this Perl file. This W option here just tells it pop up a bunch of warnings. Oftentimes it's a really good idea to have that. You might be surprised at what it turns up. And here I just put in a comment about the program itself. I always like to do that with my programs. Comment up at the top what it's for in case I have to come back and develop it later. What did I do this for? Now I know. Let me give you a bit of background about how I do my C++ projects. I will have a directory for the project itself, and then I will have two subdirectories, one called main and another one called src. src is the source files for the project. Like if we look in here, we'll see we have our main driver program cpp, and this is a backup file that my text editor generated. Over here in the main, this is empty right now, or it should be at least. This is where we're going to put our binary program, our executable binary that Linux will run. Alright, so after we get our shebang and our comment at the top, the next thing we're going to do is declare some variables. This variable right here, output file, main, this is what we're going to call the program that we're designing. It doesn't have to be anything fancy. I like to use main because I know what it's for, and I use this variable for not just the file name but also for the directory name as well. Permissive. This variable, I use this as a flag in my command line, and we'll get to that in a minute. Basically, it just makes it a lot easier to compile a C++ program. C++ is kind of strict as far as programming languages go, and this relaxes the rules just a little bit to make it easier for you. Okay, files from folder. This is a list. This is a list variable right here, and what it's doing is it's going to get the output of this command right here. ls, Linux command for list all the files in a directory. b1, this will omit certain files, omits binary, and also the backup files here, because all we're looking for really is text files. And these are the files that we're going to compile. The C++ files that we're going to compile themselves. And we have this variable empty because we're going to tell the program to fill it for us. This loop right here, for each file from the files from the folder. We're iterating through this list. In each file from this list, we're checking it out. Chomp, we're just removing the end line character at the end of the file name. Unless D file, this D right here, this /D, this is a test to see if this is a directory. If it's a directory, then we just move on to the next one. Exit this statement and go back to the top of the for loop. If T file, this T option here, this is searching to see if it is a text file. If it is a text file, we're going to execute this. Unless the file equals this variable right here, this is a special variable in Perl. This variable means the name of this program that we're working on right here, this one. If the file that we're looking at happens to be this Perl program, then we're going to just opt out of it. We're not going to execute the next statement. But if everything clears, if everything is the way we want it to, we're going to push this file to the end of our list here. This is just a debugging statement. We print to the screen the files that we're going to be compiling. Our input file, we're going to use this for the command line. We're doing the join function here. We're joining all the elements in this list, files to be compiled, with a space in between them. So we're just making a big string out of this list. This is our command line option right here. We're just generating a string that we're going to put into the shell. We're going to use G++ as our compiler. Always do this option when we're compiling with G++. Our input file, remember main up here, and our output option. These are the, back up. Our input file is from this list right here. The O is our output file option, which is main, this variable up here, and our permissive flag that we had set up here. We're going to create a flag, set it to 0. We're going to use that later when we have to do some Boolean logic. And then we execute the command inside the backticks. Now these backtick operators, one of the greatest features of Perl in my opinion. This captures output that is sent to standard output, std out, and it will redirect it into whatever variable you have it assigned to with this assignment operator right here. Now, this is where it can get a little tricky because G++ does not send output to standard output. It sends it to standard error, stderr. So, we have to redirect that output from standard error to standard output. And that's what this is all about right here. You must include this at the end of your command to take standard error and put it to standard output. Otherwise, this will not collect anything and the Perl program is not going to operate correctly. So we have our output collected. We're just cycling through each and every line in the output. And we're looking to see if the output has an error. If this line of the output has an error, we're going to trip our flag. This flag, we need this flag for later. We'll explain that in just a minute. And then we're going to print our output. And this next line here, it's kind of optional, but I like to have it. It'll print warnings. Sometimes a C++ program will compile, but maybe there's something in there that you did not intend to have happen. You might be comparing an integer with a double, and it'll let you know that. And it'll still compile, but it just wants you to know that. Maybe it'll present a logic error later. And I like to know those sorts of things, so that's why I include this statement here. If we have a warning, we're going to print it to standard output. Our flag, this is why we needed our flag here. If our flag is set to 0, meaning this statement never executed, if we never found an error, then our program compiled successfully. Just have a print statement letting the user know this, and I like to kind of offset it, the new line character and a few spaces just to make it stand out a little bit. Put another couple new lines in there. Now, we have our binary program compiled. We have to change the file permissions on it so that we can execute the file. This is very important for Linux. I struggled with this whenever I first started using Linux because I was putting my C++ projects on a flash drive, and my flash drive was using a FAT file system. It wasn't using ext2, ext3, or ext4. It was using it in a manner that it could be read under Windows. And Linux will be able to read from it. It'll still be able to read the file allocation table. It'll read Windows partitions, but it can't assign permissions to them. And Linux will not run any program if it does not have the permissions, which is actually a very great security feature of Linux for those of you who are new to the operating system out there. Alright, so we're going to execute chmod. Chmod, just a Linux utility. 755, it's an octal code. 7 is user can read, write, and execute. And then 5 and 5 is all others, the groups and the user groups, whatever that may be. Everyone else can read and execute the file. Output file, it was our variable that we declared up here at the top of the program, main. Now that we've created our file, we're going to want to move it from the source file, from this file right here, or this directory right here, we're going to move it from that directory to this one, to main, just to separate it out. So we call mv Linux utility. It takes this file, moves it up one directory, and into this directory right here, which happens to have the same name as main. Then we changed our directory, changed the focus of this Perl program to this directory that we just moved it up to, right? Notice those are the same. Now we're executing a system command to the shell, execute this file right here, main. Now if our flag was tripped, if our flag is not equal to 0, we're going to execute this. None of this is going to happen, and we're just going to send an output message to the user, errors in the source code. Seems simple enough. Save our file. Let's copy it here. And when we copy it, we're going to put it into our source file, or source directory rather. Click, drag, copy here. Alright, we're going to open a terminal in this directory. Then we're going to tell Perl, hey, execute that program, compile. Okay, see, so we have main CPP. Notice it did not pick up the compile Perl program or the backup file. This is the only one that we wanted to compile with. Main compiled successfully. Begin executing now. And it was just a simple hello world program, just a little output statement. This is just to let you know that the program worked. So where's our binary program? Remember, back up here and into main. And this is useful. I like doing it like this because sometimes I write programs that will read from a text file and generate some output as a text file, and I don't want those text files getting confused with my source code, so I keep my source code completely separate from my executable binary code and whatever files that binary may use. I hope this was helpful. Enjoy!